Right, so I was looking at this slide here. Actually, now I need to check something else first. I'm just wondering actually if it's recording, so just how do I find that out?
It says recording on my screen.
Okay, yeah, okay. Uh, Good. Right, so the idea of messaging is to decouple your compute components. And so that's what we're looking at here on the screen. Our two compute components are lambdas. And rather than they interacting with one another directly, as in this communicates directly with this lambda, presumably this lambda is doing some work on behalf of the lambda on the left, but rather than the one on the left directly communicating with the one on the right to do that, uh, instead, this lambda here puts the necessary data that it wants processed into the queue, and this lambda, via the lambda service as we know now, polls the queue periodically for data and does its processing. That now means that this lambda here is no longer waiting for the lambda on the right to do its processing. Once this lambda gets a response from the queue saying, yeah, I've got your message, then it can complete really, and it can respond back to whoever is interacting with it, which could be an API gateway, which is talking to a client, and the client now gets back a response saying their request, well, in this case, it's not so much that their request has been handled, but is being handled, because we don't know whether has started processing the request or not. And this type of architecture is fine for many situations. Clearly, it's not suitable if the processing done by this Lambda is critical in terms of the response that goes back to the client on the extreme left. If the client on the extreme left needs to know as soon as possible when all of the processing is complete, then we can't really, um, or it may not be suitable to introduce this kind of messaging middleware. Okay, now, and we looked at the basics of how this worked the last day from a programming point of view, how we program the consumer, how we program the producer. But the where we finished the last day was if this Lambda, for whatever reason, cannot process the batch of messages that it receives, then the way SQS works is that batch of messages is put back into the queue, and at some later stage when the consumer polls the queue, it will get the same messages again. And it may still fail in processing that batch, not because maybe all of the batch is faulty, but a subset, and maybe even only one message in the batch is faulty. Faulty as in it's incorrectly structured message. It can't handle it. Um, uh, you see what's going to happen is the batch of messages are going to be continuously put back into the queue and being reprocessed time and time again by this lambda, and that clearly doesn't make sense. But that arises, and so the SQS service provides a solution to that scenario, and the solution is referred to as this dead letter queue solution. There are many reasons why this lambda may not be able to process the batch that it received. It may be because the actual message is faulty. or incorrectly structured. It may be that this Lambda is using some other service as part of the processing, and that other service is returning, let's say, a throttling error, which means it's too busy, which causes this to fail, or the service that it's dependent on um, does not complete its processing in time, in which case this Lambda here actually times out. It's not that it's throwing an exception, but it just times out. Um, and there are other possibilities as well. Okay, so how does this dead letter Q work? So if we go forward then to really where we left off, which was, let's see, where am I? Yeah. So again, so this is kind of showing what I was saying, that the queue repeatedly tries to get the consumer to process the batch of messages and it's repeatedly failing. So the retrying keeps going on and on and on. Now we can set a limit to that. Um, and so if that limit expires, what the SQS service will do is it will send that batch of messages into a different queue, removing it from this queue, and so hopefully getting rid of the constant retrying that's going on here. Now, the messages in this queue, okay, we need a Lambda to process those, but at least this Lambda that's processing those, its sole purpose is to maybe pick out the particular message that was faulty and report it to whoever, send an email to somebody saying that there was a faulty message, or we don't really care about the nature of the processing that's going on here. All we want to do is relieve this consumer from being constantly requested to process a message that it cannot process for whatever reason. Now, to demonstrate this, um, I should also just remind you about when I say the batch of messages are put back into the queue, it's not so much that, it's more this visibility timer expires. I was talking about this the last day. And again, just to remind you, so the consumer polls the SQS servers for messages. It gets a batch of messages. That batch of messages are left in the queue, but their visibility timer is started. And the consumer has to complete the processing of that batch and also explicitly request the deletion of that batch. It has to do all of that within the visibility time period that has been assigned to that batch of messages. The messages are still in the queue, but because their visibility timer is ticking, then no other consumer, because there could be other consumers, can see those messages. So if another consumer happened to poll SQS for a batch of messages, it would not get the batch that was given to this consumer because their visibility timer is still uh, going, if you like, still ticking. Um, so that's really how, when we talk about um, batches being resent and how a batch is never actually sent to multiple consumers at the same time. It can only be received by one consumer. Okay, anyway, so this is our scenario. So we've got really a Lambda over here, which is really a test harness. It's generating a batch of orders, Maria. They're being sent to this particular queue, and we've got a Lambda on the right that's Maria processing those orders. And then if we've got this kind of problem with the processing that's going on here, the faulty batch are sent to this queue here, and SQS takes care of that. And I've got another Lambda over here, which is processing this queue. It's a consumer for this queue. It doesn't do any processing, it just displays the messages. So if we maybe just look through the code for this scenario or for this use case. Okay, so my VS Code now hasn't restarted since my computer crashed, so I need to restart VS Code. Okay, let's just quickly walk through the code. I'm going to start with my data types. Okay, so I've got an order type. So an order has these properties, all mandatory. Then I just created a bad order type as well, where I made all the properties of order partial. Okay, so they're optional, partial meaning optional. So that's fine. And I've declared a type called order mix. An order mix could be a valid order or a bad order. Okay, that's straightforward enough. Here is the lambda that generates the orders. Maybe if I look at that first. We had a glance at this the last day, but so it's just a for loop that's generating it's generating all valid orders, and I'm generating 10 of them. And each order, its customer name is user followed by just an index value. So that means I'm going to have an order for user 0 because I starts at 0. I start at 0, all the way up to an order where the username is user 9. Then I come along and I take one particular order out of that array and I put in a bad order. That you might remember the splice method associated with arrays. So I put in a bad order at position in the 6th position. In the within my array. So this order here doesn't have an address property. Okay, so that means now that this array that I'm creating is an array of type order mix because it has all good orders, but it has it has a lot of good orders, but it has one bad order. And then the rest of the code in this is just concerned with sending that array to an SQS queue, okay, which we kind of talked about the last day. If I now look at the stack file, and in my stack file, I have the queue that's going to be holding the bad batches. I have the main queue, if you like, but in the main queue, I am actually configuring a dead letter queue for it. Okay. And there are a number of properties that you can configure. The only one that's of interest is this one here. What that is controlling is how many times the SQS service will resend the batch to my main Lambda. In other words, how many times do we want a batch to be resent back to this Lambda here? And I've said only once. So once this Lambda gets a batch that it cannot process, that batch is immediately sent into this queue. Okay, done that just for simplicity's sake. Okay, so and the rest then of the rest of the code in my stack is pretty predictable kind of stuff. So this is the Lambda that processes orders. And so if we maybe look at that next, that's this guy here. Again, doesn't do anything really interesting other than we know it receives a batch of messages, which is why I've got my for loop. And within the for loop, I am checking to see if any order is invalid. Just using that AJV library that we know about. And so we know that there is going to be one order that's invalid because we put in one that didn't have an address property. So at some stage, as it's processing a batch, um, it's going to throw an exception, and throwing that exception is really what's going to trigger the Lambda service to tell SQS that the batch that it gave it could not be processed. And given the way I have configured my dead letter queue, that means that particular batch is going to be sent to the dead letter queue straight away. The rest of the code in my stack file, I don't think there's anything particularly unusual there. So this is the Lambda that processes message from the DL queue. This is the Lambda that generates the messages. And then I just hook things up, right? So all I'm doing here is connecting the main queue to my process orders function. I'm connecting the Lambda that processes bad batches to the dead letter queue. And I'm just giving the Lambda that generates the orders permission to write to the queue, and that's it. So if I now, what I need to do is I need to trigger this Lambda here, and that will kick off the whole execution sequence for me. So if I just check in CloudWatch that it's empty. Yeah, it looks good. So I just need to trigger the order generation Lambda, which I did before the lecture. So I think I can recall the command here actually. I think that's the command. Okay, and if I go back to here and do a refresh. So that's the Lambda that's generating the orders. The Lambdas that processes the messages in the queues haven't been triggered yet because that's based on polling, so there's a slight delay. But if I refresh again, now the Lambda that's processing the main queue has been triggered, and we can go straight into that actually. Now I have configured the concurrency level for that Lambda to be 2, so there will only be 2 parallel instances of that Lambda generated by the Lambda service, and it will essentially split the array of 10 into 2 groups. It doesn't have to be 5 and 5, it's completely random. So one of these 2 log streams is going to show that it received the, I should just go back to that, sorry. So I'm sure you picked it up if I go back to here. I gave the name user X as being the customer user for the bad order, and in the console log of the process orders, I am console logging the username or the customer name of each order, just to make it easy for me to spot it in the log stream. So if I go into my two log streams, let's see. So that's user 5, it's user 8. Okay, so it looks like this log stream, first one got the bad order, and you can see straight after it, if we expand this, it threw an exception. So that's what we're seeing here. The other log stream, this one got all good orders, but because the orders that both of these concurrent instances received, because the orders were sent as one batch, well, maybe not actually, maybe no, actually, it's only the orders that this one received. They're the ones that are going to, I'm just thinking actually, maybe which way does it work? I think the entire batch is sent to my dead letter queue. Yeah, I'm pretty sure that's how it works. Let's go back to the log groups. And if we refresh, we now have the third Lambda has been triggered. That's the one that's processing bad batches, which is this logs group here. It also has two parallel instances. And so if we don't have to go through them in detail, but if we went through the two log streams, we would essentially find all of the messages that were in the faulty batch. Now we really only have one batch. Let's just see for the sake of interest, which of these ones got the user X one. That's user 8. It's user 7. So it must be the other one. User 5. User 0. And there's user X. Okay. Now, let me just go back to here. So for a particular, I just ran it once myself before the lecture. And so we know about this, right? This is the scenario. The max concurrency is set to 2 for both of my lambdas, my process orders and the one that handles the bad orders, etc., etc. And this was just what happened, if you like. So my two concurrent instances of the process orders function, one of them received a sub batch, if you like, containing the order for user 0, user 4, user 7, and user 9. The other one received user 1, 2, 3, 5, and X. And then when I looked at the log streams for the Lambda that processes bad batches, one of the concurrent instances received user 1 and 3 and 8, and the other one received 2 and 5 and X, which means 1, 2, 3, 5. 1, 2, 3. Yeah, which means it's actually only the Lambda that got the kind of sub batch, if I might call it, the sub batch of that contained the bad order. It's that sub batch that was sent on to the dead letter queue based on what I'm showing you here. So it's not the entire initial batch. Okay, so anyway, that's just dead letter queues, and so their function is to deal with error scenarios in your consumer. There, and it's usually kind of an edge case, but you have to deal with those edge cases. Because if I go way, way back to that initial slide that I had, you know, the lambda on the left never, if you like, it never waits around to find out whether the lambda on the right did its processing, was able to complete its processing or not. So this lambda doesn't handle any exceptions that might be thrown by this lambda. That's one of the consequences of introducing this kind of middleware, if you like. Okay, back to here. Okay, so all I'm showing you in these, the next 4 slides are just screenshots from CloudWatch streams for this particular scenario that I got. Okay, so I don't need to talk through those really. I'll skip over those. Now, what if we didn't actually configure a dead letter queue at all? What would happen? And so let's just do that. So if I go into my stack and if I just take out this code here, which is simply essentially just disconnecting my dead letter queue from my main queue. Okay, and redeploy. Just let that work away. Now, is this just going to take too long? And if I trigger the whole execution sequence again, now it'll take a little bit of time to prove it to you, but what actually happens is, go to the slides. So because this connection now is gone, essentially SQS is going to just continuously retrying to get the Lambda to process the batch. Now it does give up eventually, and by give up, we mean, it just deletes the batch from the queue, but no other part of our application now ever knows about the fact that there was a bad batch. And the retrying goes on for quite a while. And so what I just want to show you is proof that it does keep retrying to get the all of the messages processed. So it's working away now as I'm speaking, but what it does is it follows what's called this back-off exponential or exponential back-off algorithm. What that means is um, it the first time Lambda service polls it for the messages, it sends the batch in response to it. It sets its visibility timeout period. Uh, let's say it's uh, 10 seconds. It then later on it's told by the Lambda service that the Lambda threw an exception. What the SQS service does then is it delays for double the visibility period, 20 seconds before it tries again. After that, the Lambda service will eventually tell it, no, I couldn't process it. It will double the timeout period again and keep on trying. But there's a bigger time gap between each time the SQS service sends the batch back to the Lambda, because the SQS service kind of thinks that the only problem is that the compute, the consumer just doesn't have enough time to do its processing. So it's kind of giving it more and more time. But it's not time is the problem in our case. The problem is that, there's a faulty message and it just can't be processed. So I just want to show you how that looks in the log stream. So we'll see in the log stream uh, kind of confirmation that it's just constantly retrying and retrying. So we don't have any dead letter Q in this case, so we only have two log streams, and it's the logs or two log groups, and it's only the log group that's doing the processing, which is this one here. And some of these now are legacy ones, unfortunately. I'll just go on the timestamp to see which are the most recent ones. So it's these two here. Now, this is kind of proof of it, right? So it's a very, very log stream or long log stream. So what's actually going on here? So this log stream, as we know, is showing the execution for a particular micro VM instance that's running my process orders Lambda function. And I haven't spoken about this before, but the first entry in the log stream, the init entry, remember when I was talking about Lambda way back, I talked about cold starts and warm starts. A cold start is when the Lambda's initialization code is executed and the actual main handler function is executed within the Lambda. So what this is telling me here is that it has ran the initialization code for my Lambda, and then it starts to execute the handler itself. If I scroll down, this is the end of the execution of the handler, but it actually starts again. So this is the second execution of my Lambda, but there's no need to run the initialization code. It's now just running the main handler function itself. In other words, this is a warm start, whereas the previous one was a cold start. And we have another warm start. And you could look at the timestamps on them. You can see the delays between them. And it keeps on going. Okay. And the reason that's happening is because SQS just keeps resending the batch that contains our user X order, keeps resending it back to my consumer, which is my Lambda in this case. And that will just keep on going for quite a while. I'm not sure what the upper limit of it is. It could even be days. So I guess it would be a good idea if I destroyed that stack now because it's just going to keep going. Back to my slides. Okay, so I'm just summarizing anyway what we have been covering over the last 2 days. What is SQS? Okay, it's a messaging service. It's all about decoupling your compute components. Why do we want to do that? We want to uh, decrease the response time back to our client because rather than our client waiting for all of the processing to complete, all it now waits for is that it waits for the Lambda that puts the messages into the queue. It waits for that Lambda to complete, and then that Lambda can respond back to our client. Okay, so we're decreasing the response time. It also potentially improves the whole scalability of our application. When we're talking about SQS, there's two actors, I'm calling them, your producers and your consumers. You need to remember that the consumer is not triggered by SQS. The consumer actually polls SQS for messages. If the consumer happens to be a Lambda function, then it's the actual Lambda service that takes care of the polling. We don't have to program it in our Lambda functions at all. The Lambda service takes care of it, and also the Lambda service takes care of handling scalability on the Lambda function side. And when you've got messaging, you have to then also have to consider how should error cases be dealt with. And we've just been looking at that. Fortunately, the SQS service provides this dead letter queue mechanism for catching error cases. And so I'm just saying here, by default, we know that the SQS service now keeps retrying when a batch is not processed by the consumer. It just keeps retrying the consumer to complete the processing. And okay, I'm saying here it does it infinitely. Well, it's not infinitely, but it's certainly much longer than what we'd like it to be. Okay, so that's SQS. I'll just pause for any questions in case there are questions. I don't ever get questions from you, but anyway, that's okay. So if I go back to my website, I want to move on to this set of slides here, which is dealing with the other, or a second messaging service that's provided by SQS, and this one is called SNS. So let's bring up those slides. Now I'm going to stop sharing for one moment. Okay, so we're still on the topic of AWS integration and messaging services, and the one I want to look at, as I said, is this one here, SNS. And essentially, the difference between SQS and SNS, even though I wouldn't have used, sorry, SQS is essentially what's kind of referred to as a point-to-point messaging service. I didn't use that term, but what that really means or is that even though you can have multiple consumers associated with an SQS queue, we could actually have had more than one Lambda. I'm not talking about concurrent instances of a Lambda now. I'm talking about two separate Lambda functions or more. We could have had any number of Lambda functions as consumers for a single SQS queue. But the way SQS works is when the Lambda service polls the SQS for messages from a queue, it's polling it on behalf of one of the consumers. And so SQS will return back a batch and it'll give that batch to whichever consumer initiated the polling. If the Lambda completes the processing of that batch, then Lambda service will delete or request the deletion of that batch from the SQS queue, and no other Lambda consumer will ever receive that particular batch. So it's only one of the consumers that will receive any particular batch. Put it another way, the same message will never be processed by more than one consumer. That's just the way SQS works. Equally, even though we didn't deal with it either, equally, you could have multiple producers writing to the same SQS queue. But the point-to-point kind of characteristic is more on the consumer side, this idea that only one consumer will ever see and process a particular message. Whereas with SNS, it's referred to as a pub sub style of messaging, which means that if you have multiple consumers, although we don't refer to them as consumers, but we refer to them as subscribers. Let's just use the language of SQS. If in the case of an SNS messaging middleware, you have multiple consumers, then each consumer will receive each message that has been put into the SNS messaging middleware. Okay. And so you obviously choose which of those two scenarios you want for your particular messaging middleware. You either pick the SQS one or the SNS one. So SNS is kind of classically referred to as a pub sub messaging middleware. And pub sub is a byword for or a term for the idea that all of your consumers will receive all of the messages that are available in the messaging middleware. As I said, we don't use the terms producers and consumers. When we're talking about SNS, we talk about publishers and subscribers. Publishers are the ones that write messages to the SNS middleware. Subscribers are the compute components that processes those messages. Also, we don't talk about queues in relation to SNS. We talk about topics. Okay. So a publisher will write a message to a particular SNS topic, and a subscriber subscribes to a particular topic. The subscribers you could actually have, and it's a very common pattern, You could actually have SQS as a subscriber to an SNS topic. You could have an API gateway or a load balancer as a subscriber to an SNS topic. That's what we mean by HTTP and HTTPS. And of course, a Lambda function can be a subscriber. As well, we could use the SES service as a subscriber. So as messages are written to an SNS topic, if that topic has an SES subscriber, that will actually trigger the sending out of emails to whoever whatever way it has been configured, the subscription has been configured. Or you can have an SMS messaging subscriber as well. So lots of options available to you on the subscription side. And there are lots of options available on the publishing side as well. And in the lab, as you know, you're using S3 as a publisher to an SNS topic if you've worked your way through the lab. Integrated with lots of services. Yeah. So on the publishing side, a Lambda could be a publisher, S3 could be a publisher, CloudWatch alarms. You can hook up a CloudWatch alarm as a publisher to an SNS topic, and there's lots of other ones as well. There's lots of encryption happening as well. We talked about that in relation to SQS. We talked about in-flight encryption and at-rest encryption. So the same applies to SNS topics. Message filtering is something that we'll look at later on, but when we're talking about SNS, the publisher is writing messages to an SNS topic. The subscriber is receiving messages from an SNS topic. And there's also what we refer to as the subscription. So when you want to hook up a subscriber to a topic, you have to essentially create what's called a subscription. So if you like, the subscription describes the nature of the connection between the subscriber and the topic. And you can configure the subscriptions such that there is some filtering performed by it. So it may not allow all messages to go to the subscriber. It filters out certain ones, and you can configure the filter. And we'll see how to do that next week. Security, similar kind of security model, really, as was the case with SQS. The publishers and the subscribers have to have the relevant IAM policies for all of this to work, right? And you can also control who can access a particular SNS topic from other kind of AWS accounts, even though we didn't look at any of that in relation to SQS either, and we won't look at it here. But it's all the usual kind of security stuff, which is central to AWS, as you know. By auto scaling here, I simply mean that your topics can scale up as much as you want them to. So the volume of messages that are being written to an SNS topic is quote unquote infinite. There is a DLQ facility built into SNS, same kind of idea. If subscribers are not able to process a message, or more accurately, if the SNS service cannot deliver messages to a particular subscriber, then what do we do with those messages? Well, we can actually configure a DLQ to receive those messages, and then you would typically have a Lambda then that's consuming the messages in that DLQ. So the DLQ option here is more for cases where SNS cannot deliver messages to the subscriber. It's not so much for cases where the subscriber receives a message and it throws an exception. Okay, that's a different, that's not dealt with by SNS at all. You'd have to actually configure your subscriber to deal with that. And I'll show you how to do it when the subscriber is a Lambda function. So just be aware of that the DLQ is more from SNS's inability to deliver a message to a particular subscriber. So an SNS topic, okay, it's a logical access point. Okay, so I've kind of already explained this in words, but here's just a visual of it. We've got one publisher, although you can have many. And the whole idea is that you can have many subscribers, and each of these subscribers will receive every single message that has been written into an SNS topic. Okay. Demo as usual. How do I create an SNS topic? This kind of stuff now, I think at this stage, hopefully it's becoming almost predictable, right? So here I'm just creating an SNS topic, simple enough. Here is, let's supposing it's a subscriber, I think. I've collapsed it a bit, but it's just a Lambda subscriber. And here's how I make that Lambda. It's just an ordinary Lambda, but here's how I make the Lambda a subscriber to the topic. Okay, so it's pretty simple. Although maybe just to what you're essentially doing here now is you're creating the kind of subscription resource. Remember I said that you've got the topic, you've got the subscriber, and you've got the subscription. This line here is essentially creating the subscription resource to complete the chain, to complete the connection between the subscriber and the topic. And you can configure, there's lots of configurations that you can do on subscription. We're not doing any here, but for example, it's where you would specify the filtering that you want to have performed. And really, there's nothing special about the Lambda other than the only thing that one would be interested in is to see the structure of the event object that the Lambda receives. And within that event parameter will be the SNS messages, because SNS works in batches as well as SQS. I think I say that. Yeah, okay, so that's what's being shown here. So when you've got a Lambda subscriber, what it receives is a batch of messages. Now, the reason I've got a question mark here is because we're actually going to contradict that. I'm going to contradict this statement later on. And I've only kind of discovered that from reading a little bit deeper into the case where the subscriber is actually a Lambda. Turns out it doesn't receive a batch of messages at all. It turns out that for every time a message is written to an SNS topic, if that topic has a Lambda subscriber, then the Lambda subscriber is kind of triggered for each individual message. However, what I'm showing you here is a screenshot of a console log of the event parameter that is sent to my Lambda subscriber. And within that event parameter, there is a records property. And the records property is an array, as we can see there, okay? And in this array is the array or the batch of messages that has been sent to my Lambda subscriber. So it's a bit of a contradiction, I know, but that's for now, we'll just stick with the idea that it is a batch of messages that the subscriber receives. We'll kind of conveniently ignore the fact that I've got a question mark here over it. And here's confirmation from the console log of the log stream associated with my particular Lambda subscriber that it is actually receiving an array of messages. And let's supposing, well, in my case, for this simple little demo case, I'm using the CLI to send a message to my SNS topic. So this is the CLI invocation. Do I show the message? I don't, but the message, maybe if I just load in that demo into VS Code. Okay, so that's my message. And that's what we're seeing. Is it what we're seeing? Yeah, that's what we're seeing here. And as before, as with SQS, the message is serialized, so your Lambda would need to parse the actual message. But the main point I want to make from this slide is the fact that from the Lambda subscriber's perspective, you've got to treat um, you've got to assume that it's an array of messages that you're receiving. Okay, and that array is contained within a records property within the event parameter that's passed to your Lambda function. Now, I'm not going to run this demo because it's kind of trivial, so we'll just move on. This fan out pattern is a very common pattern that's used, and a pattern is a sort of architecture structure that you see a lot when SNS is being used. And the pattern is that you have a number of subscribers, and in this case, what's often like there are different versions of this fan out pattern, but one version is where the subscribers are all SQS queues, and each of these queues has a Lambda consumer. Okay, and so my publisher writes messages to my SNS topic. The SNS service forwards on those messages to each of my SQS queues, and the Lambdas over here, the Lambda service is polling these queues, and we know how that works. You know, this Lambda is going to receive a batch of messages from the queue. Okay, but it's this kind of setup that we see quite a lot. Now, in my case, in this simple case, all of the subscribers are SQS queues, but you could have, you know, a Lambda here, which is also a direct subscriber. Okay, so a Lambda could be a direct subscriber, or a Lambda could be what I'm just going to call an indirect subscriber. Indirect in the sense that it's going via SQS. Now, why you would use one over the other, I talk about in a later slide. There are cases where it's better to actually have the Lambda as a direct subscriber, and there are other cases where it's better to have the Lambda as a consumer for an SQS queue and have the SQSQ as the subscriber to the SNS topic. Okay, but for now, just we're only interested in, look, this is a kind of a setup that you might often see. To illustrate it, and my illustration is kind of veering away a little bit from this kind of the previous slide, but let's supposing I'm going to use the AWS CLI as a publisher to an SNS topic, and my topic has two subscribers. One is a Lambda function, which is a direct subscriber, and the other one is an SQSQ, and my SQSQ has a Lambda consumer. So really the purpose of this demo is to show you A, fan out, B, the difference between this Lambda and this Lambda. And at the end then I'll talk about why you would choose one over the other. And it depends on the nature of the kind of messages that are being sent to the SNS topic. Okay, so that's my architecture. And maybe if I just switch over to the actual code. So it's a different one now from this one, actually. Let's look at the stack file from the top down. Okay, my SNS topic, nothing interesting there. Here's just a queue, an SQSQ. I've got a Lambda, and just based on the name, this is the Lambda that is going to be a direct subscriber to my SNS topic, but it's just a Lambda. Okay. This is the Lambda that is the consumer of the SQSQ. And then I kind of hook things up. Here I am adding a subscriber to my topic. And this is a Lambda subscriber. And I'm referring to one of my Lambda functions above, the process SNS topic Lambda. Here I am adding another subscriber, but in this case it's an SQS subscriber, and I'm referring to my SQSQ. So that's the kind of architecture completed. What am I doing here? Oh yeah, here I am just adding a consumer to my queue. Okay, we've seen this already. So that's adding the consumer to the queue. And that's it. And I'm just outputting the ARN of the topic so that I can trigger it or invoke it from the command line. I can send messages into it. So if I deploy this, which I probably should have done before I started talking, but CDK deploy. We let that work away. The message that I'm going to be sending to my SNS topic is just that standard one that I've been using. Where have I it? There. Okay, that's the message that I'm going to be sending. And if we look at the, well, they're actually not that interesting, but if we look at the lambdas, so this is the lambda that's a direct subscriber to the SQSQ. Okay, I'm just console logging just to see the structure of the event parameter that's passed into this Lambda, I have to do, 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 do. Oh yeah, you can see here, right? I'm just picking out the first message in the batch. And the reason I'm doing that is because I know that there is never going to be more than one message in the batch. This is kind of what I was talking about there earlier on. But I suppose, strictly speaking, I probably should have put a for loop that iterates over the messages, but that for loop is only ever going to iterate once. So I'm picking out one particular message, index 0, within the quote unquote array of messages, and I'm picking out a property within that message. So it looks like SNS.message will eventually drill down into the actual message that was sent into the topic in the first place. And I am just doing some validation now of it, but we could ignore the validation for now because the same question kind of arises, what if, so this is the direct Lambda subscriber. What if that Lambda throws an exception? Who deals with that? And I'll show you how to configure a way of dealing with it. Because SNS will not deal with it as long as SNS was able to deliver the message to the subscriber, then it doesn't care about the fact that the subscriber may have not been able to process the message. So it's kind of out of the loop. This here is the Lambda that is a consumer of the SQSQ, which is the SQSQ is the subscriber, and I'm doing even less interesting stuff in there. All I'm doing is console logging the event parameter, but it's informative to always look at the structure of the event parameter that's passed to a Lambda, because we always need to know what is the structure of the event parameter. And certainly if the event that's triggering the Lambda is, SQS, SNS, or other kind of middleware. And this Lambda here, we can ignore for now, actually. Okay, so my stack has deployed, and I need to kind of trigger its execution flow. So if I just bring up my README here, which has the message that or the CLI command that I want to use, which is this command here. Just need to change the ARN of the topic. Which is this. And I'll just check to make sure my CloudWatch logs are cleaned out. So before I hit return now, I'm about to publish a message into the topic, and SNS will forward that message onto my two subscribers, which is a Lambda and an SQSQ. I would expect the Lambda subscriber to show up almost straight away in my log groups, but the Lambda that's linked to the SQSQ, that will not show up straight away because, of the way the Lambda service polls the queue. So there'll be a slight delay. So can I copy that? Oh, yeah, sorry. Okay, so that's the Lambda, that's the direct subscriber. And if we just look at the log stream, not that interesting, but all we did in the log stream was console log the event. And so, as we said, okay, it receives a batch of messages. There's only one message, and I think if we drill down into it, here's the message here in serialized form. Back to my log groups. Second Lambda should have been triggered at this stage. Yep. Okay, so yeah, so what I'm showing you here are just screenshots from the two Lambdas, screenshots of their event parameter, and showing you where the message can be found within each event parameter. So this looks like it's the one that I've just shown you, the log stream from the Lambda that's a direct subscriber. This is the Lambda that's a consumer of the queue, where the queue is the subscriber. Okay, and you can study those yourselves at a later stage. Now, that's fine. There is this thing called the SNS envelope, and it only applies when SQS is the subscriber to your topic. When that is the case, then SNS wraps the message in an envelope, and that's what it actually passes on to the SQSQ subscriber. And you can control whether you want that envelope to be included or not. If you've got a very high volume of messages, then the actual amount of data that's being sent between SNS and SQS can be significant, because the envelope is usually much bigger than the actual message itself. So it's a lot of additional data. It has its uses though. But either way, the message that was written to the SNS topic is wrapped in an envelope, and that envelope is what is sent to the SQSQ. And we actually saw that, we saw it here actually. So, all of this stuff here is the envelope and down here as well. I think I have a separate kind of screenshot of it. Yeah, so this is again a screenshot from the Lambda that is a consumer of an SQSQ where that SQSQ is a subscriber to a topic. And so the outer box is the actual message, but all of this stuff here and this stuff down here is the envelope. The actual original message that was written to the topic is in the inner box. Okay, now you can control whether you want SNS to carry out this enveloping or not. And so that's a property of the subscription. So this is the first property of a subscription that you can control. So the raw message delivery, if you set that to true, then you're saying do not include the envelope. If you set a default, you're saying do include the envelope. And I think the default value is false. So that's an example of where the envelope is included. This screenshot is from the exact same Lambda where the envelope has been disabled. And we can see now that the message, the overall message is much smaller. Yeah, okay, it's this box here compared to this box here. That's the SNS envelope. I think that's as far as, okay, let's deal with this slide. Just check my time. Yeah, we're okay. So I did mention this way back when I started talking about SNS. I was saying that you can have a Lambda that is a direct subscriber, or your Lambda may actually be just a consumer of a queue where the queue is the subscriber. And so why would you choose one over the other? And that's what I'm kind of elaborating on here. So I'm giving you, first of all, the disadvantages of having a Lambda, which is a direct subscriber. And here's the first point, right? There's actually no batching happening at all. Now that does contradict when we go back and look at, let's get an example. Okay, here's an example of the event parameter associated with a Lambda that is a direct subscriber. And this Lambda, we can see that based on the structure of the event parameter, it looks like it's receiving an array or a batch of messages. But as I've already said, there's only ever one message in that batch. I think this may be a throwback to when SNS came out originally. SNS was released in 2010, and that predates Lambdas. And so the main the main subscribers back then would have been EC2 instances. So it's perhaps a throwback to then, where the need for batching would have been more relevant, let's just say, without going into explaining why. Whereas when Lambdas came along, much more lightweight, then SNS can actually deliver each message individually to the Lambda subscriber. That's the only rationale I can make for it. It's not a great rationale, but anyway, when I dug down and researched this a little bit, it was actually in Stack Overflow that I got an explanation as to, what's the difference between this approach and this approach. And so we're getting some of the explanation here. There's actually no batching. Also, you don't have any control over concurrency. You cannot control the concurrency level of your Lambda subscriber. So for every message that is sent into an SNS topic, that message is sent to a separate execution of the Lambda function within a micro VM. So that's it really. So if there's a very high volume of messages, then it's possible there won't be concurrent instances of the Lambda created, right? The single micro VM that's running the Lambda, that has to deal with the large volume of messages that it's being hit with. And potentially that could cause the Lambda function to return a throttling error. So you have no control over the Lambda concurrency. Number 3, Lambda functions is, the Lambda function itself is actually responsible for handling errors. I'll show you how you can do that in a while. The Lambda DLQ needs to be handled separately. So it's actually like if you want to have a DLQ linked with your Lambda subscriber such that the Lambda function itself can cause bad messages to be sent to a DLQ, you actually have to configure that as part of your Lambda configuration. You cannot get SNS to do it. Okay, so there are all the disadvantages. So you might argue, well, then there can't be any scenario where it's good to have a Lambda as a direct subscriber. Well, in fact, there is a good case. There is one good case for having a Lambda as a direct subscriber, and that's what I'm getting at here. If the nature of the messages that are being put into your SNS topic, if the processing that needs to be done by a Lambda is time critical, maybe not, it may not be compute intensive, but it is time critical. It has to be handled as quickly as possible. Then that's a good case for making the Lambda that's doing this processing a direct subscriber to your SNS topic, rather than taking this approach here. Because with this approach, the actual triggering of the Lambda is going to be delayed because of the nature of the polling that's going on. So that's the only case when it's advantageous to have a Lambda as a direct subscriber. Now, so if you are going for that case, then how do you handle errors within the Lambda? If it throws an exception, who deals with that? And we set up here that the Lambda actually has to we have to configure the Lambda itself somehow to deal with that case. And that's what I want to show you before we finish today, if I have time. I think I have some amount of time in it. Maybe we'll just look at and talk through it the next day. So if I just load up a separate project. Okay, let's look at the stack first. This is a very simple configuration. We have a topic. We have a queue, and this is the queue that we're actually going to be using to receive messages that were received by the Lambda subscriber to this topic, where the Lambda could not process the message. We've got our Lambda function, which is the subscriber to the topic. And here's the important line here. So there's this property called the onFailure property. And you can see that I'm actually linking it to my queue. So this queue is a DL queue that is linked directly to this Lambda. So there's no, well, yeah, that's it. Okay, it's a queue that is going to receive messages that could not be processed by this Lambda. And we could, I suppose it's fair enough to refer to it as a dead letter queue. And the rest then is, this is the, okay, have I got a second? This is a Lambda that is the consumer for this queue here. And then I'm just connecting things up. Okay, I'm connecting the first Lambda as a subscriber to my topic. So it's a Lambda subscriber, it's a direct subscriber. And this is where I'm connecting the second Lambda as being the Lambda that processes messages from the DLQ. And then I'm just outputting the ARN of the topic so that I can publish messages to it from the command line. The Lambdas, again, don't do anything interesting, I think. This is the Lambda that's a direct subscriber. Oh yeah, this is how I'm proving that the whole DLQ, the onFailure property, is working. So I'm checking to see that my message has an address property, and if it doesn't, throw an exception. So my messages, again, are those simple messages, name, address, email. And if there's no address, then I get this Lambda to throw an exception. This is the Lambda that's the subscriber to my topic. The other Lambda, the one that's the consumer to the queue, just console logs all the messages that it's receives from the queue. Let's just deploy it. Maybe not actually. Maybe if I'll just hold it there today. And I will look at this the next day, and we'll also look at filtering on the subscription side. And I think really at that stage, I will have everything that I want to cover with you in this module completed. So potentially I might actually finish lecturing next week. Now, fortunately, there is a second assignment specification that I need to give you, which is obviously based on all of this stuff. So whether I'll get to talk about that next week or not, but I think I may be able to finish all my lecturing of material next week anyway. So that'll give you a little bit of breathing space for all the other stuff that you have to do. Okay, I am going to stop there for now. I will accept any questions that you might have, whether it be on the assignment that you've just completed or the whole cyber the consequences of the cybersecurity breach. Don't know if you've got anything that you want to ask me. No. Okay. We'll leave it at that for now, and I will touch base with you again next week.
Diarmuid, actually, I have a question.
Mm-hmm.
In terms of the final exams due to the cyber attack, will that change or will the structure be any different? Or like what would be the structure? Is it multiple choice or just
Yeah,
question on that?
it's obviously something that all of us lecturers are thinking about because of the. So my original plan, which I am still hoping to follow through with, is that there will be what I'm calling a lab-based exam in week 13.
Yep.
That's hoping that we have internet back in the college by then. And I can talk a little bit about what that will look like when we get closer to it. There's much point talking about it now, really, but it will be about maybe a 90 minutes. I have to judge the amount of time that you need. If I'm not able to do that, then what I'm thinking about, and I was literally thinking about this this morning, it may finish up me holding what I'm just going to call interviews with each student, where I will maybe show them a little piece of code and ask kind of questions about that code. But I haven't kind of firmed up that approach at all in my mind yet. So
Okay.
that's where I'm at. So you're going to get one other assignment. There are no more labs other than the lab that you're working on now. You have to submit that. That's the end of lab submissions. One more assignment, which will be worth 20%. And then whether it be a lab-based exam or this interviews held during week 13, and that is worth 50%. So it's very significant, which is why I have to
Yeah.
put thought into it. Yeah.
All right. Thanks, Dermot.
Good. Nothing else? No. Okay. Talk to you next week.
Thank you.